Hello, everyone. Today, I'm going to demo the end-to-end flow for IH ETL nested payload feature. First, let me give a quick introduction about this new feature. Before nested payload feature, the only way for a customer to upload their raw data into ETL app is through a flat import set table. But it is very natural that from a modern system, customers' raw data is nested data such as JSON. For example, a computer that has some storage disk and the software installed. This kind of structure cannot be represented by one single flat table. Currently, customers have to do some script operations to transform this kind of nested data to several flat table data. This script transform process is difficult, time-consuming, error-prone, and not performance efficient. But with this new IH ETL nested payload enhancement, ingesting nested payloads such as JSON becomes a breeze. Now I will demo how to create an ETL map using a nested payload. The first step is to upload the customer raw data through platform data source. Previously, customer has to put their raw data into a flat data format like CSV file. This is the old format, like the CSV format they have to use. Basically, it's just row by row. After this flat data source is loaded, each column of the raw data corresponds to a column in the import set table. So basically, if they load this into their data source, and it's going to be loaded by the platform transform, and this is the import set table they're going to have. And we can see that the columns are correspond to the CSV file, as we can see here, the computer name, and we have computer name here in the CSV file. However, with nested payload feature, customer can put all the nested data into a single nested structure like JSON or XML. Let me give an example. This JSON object comes from the JMF customer's actual computer information. I put out this JSON from out-of-box JMF computer data source. As we can see here, this computer has nested storage disk, which is here. This is the storage device, which is a disk. And also we have the nested software installed here. Each nested level has their own fields to represent its information. So after this, we are going to use this nested JMF JSON data as our demo data source. After we attach this JSON file to the data source, I attached it here. We must mark the data in single column here as true. Only when this field is true, then ETL app would process this payload as a nested payload. Otherwise, it will process it as a flat payload. After this data source is loaded, each raw JSON data will be stored in the U underscore column, which is the first column here. Each row represents a computer JSON object in the raw JSON array we just saw, as we can see here. We have 3 computers here, and that is exactly the JSON structure we have. So after data source is set up, customer can go to ETL app and start creating a new map based on this data source we just saw. For the first step to fill out basic details, there is no difference comparing to the original interaction flow. This is the first step. Customer can simply fill out application information and choose corresponding data source as before and click Save here. Next is preview and the prepare data page. One very important thing for nested payload is to efficiently navigate the nested data. In prepare data page, we provide customer 2 ways to navigate in nested data. One is a tree view here. The other one is a collection view. Both views sit in the left side panel. Customer can open and close this left panel through this show data structure checkbox. You uncheck it, it'll hide. Check it, it'll go back again. First, let's talk about the tree view. One typical way for customer to navigate their data is to view a specific object in a specific level. For example, view the software installed of the second computer. Thus, inside tree view, we represent the exact nested data as a peer tree. The light green pills represent the level objects such as a storage disk here or a software installed. Each level has white pills to represent the child records inside this level, as here, the white pills. Customer can expand the child pills by clicking it, and then you can see the child records level again. If I click it, you see the light green pills as a level objects again. When customer clicks the pills, we also provide a breadcrumb to notify the object path they are currently at. So currently I'm at the first level object. If I click the software, you see I'm going to the first computer software level as here in the breadcrumb. Clicking the breadcrumb itself can also navigate to corresponding levels, which function same as clicking pills. So if I click the object, it's gonna go back to the computer level again. Each time customer clicks a level pills or breadcrumb links, the right side transform table, which is this table, will refresh to show all object information inside that level. We also added nested object columns inside the transform table to let customer know how many nested objects they have for this records. As you can see here, we have the subtitle as a nested object. You can see it's nested the software, which is here, and the storage device, so on. And then we have links here. Clicking those number link can also redirect you to corresponding level and the peer tree, and the breadcrumb will update accordingly. If I click the software here, it'll go to the first row, which is first computer software level. And then we can see all the software information we have here. Customer can also group by or search their data. They function same as standard platform table group by and the search features. For example, if I want to group by the computer MAC address here, I just click this hamburger and we see this group by computer MAC address. And clicking it, it will group by this. And the search function as a standard platform, we have this magnifier button. Let's search for the third row as F4, and let me click enter. We see that we search by the F4, this row shows up. Next is a collection view. In this view, we provide customer a holistic view of objects they have in one level. For example, customer might want to see all the software they have, no matter those software are from first computer or second computer. The left side tree now represents all the levels inside nested data. When clicking any of the level pills, the right side table will show all objects inside that level. As here, we are showing the software of all the software we have inside this data. Also, in order to allow customer to know which parent object these records belong to, for example, which computer this first row software belongs to, we added context columns in transform table to represent the parent objects. As we can see here, the first column, we have the subtitle as context column, which shows the parent information of all those rows information. And by default, we group the level objects by the topmost parent they have, which is computer object context column in this case. When customers create transform operations in nested payload, they can achieve exactly what they have been doing in flat payload version. And I have copied all the transform operation exactly from the flat payload version here, as you can see. And even better, we added a field dot-walk picker for customers to select fields they want to transform from different nested levels. Inside this picker, we will first show the topmost levels fields. This is a dot-walk picker. If I add it here, we see that all these fields are from the first level. And then we will, customer can click the dot-walk row, which is here. You can see the right arrow here. If I click this, they can navigate to other levels fields, which is here is from fields from software. For example, let's take an example as the SAM software source native key here. In the flat payload version, customer has this SAM software SN key, which is a concatenation between computer's ID and the software source native key. And they are from different levels because they are computers and software levels. Previously, they have to flatten the software data with computer data so they can create the same level transform. But with nested payload feature, customer can just open the software level, which is this level we currently at here, choose the concatenation operation here, select the first input column as a computer's UDID, which is ID of computer, as you can see here, which is from the first level. And then for the second column, go to the dot walk picker, select software level, and choose the software SNK here. Then they can achieve a different level transform operation and just click apply. It will give you results as a concatenation of the software, the computer's ID and the software's source native key. After finish creating transform operation, we will go to the class mapping page. I have already created the exact same mapping as a flat JMF mapping, but with nested payload feature, we can save a lot of extra mappings that exist in flat JMF. Let me go to the flat JMF one. This is right now I'm currently at the flat version of the JMF computer mapping. So as you can see here, the flat JMF data does strict wrap operations to flat data. So they need to add an extra computer class for each nested level class so they can be associated together. For example, for this disk class here, they have to add this disk computer. And for the network adapter, they have to add the network adapter computer just so that they can be associated together. And also because the data is flattened, they have to add an extra field, which is U_type here to make every class a conditional class. And they use this U_types value as a condition to give information about which data this data should map to which class. Like here, if U_type is disk, they map to this class. But with the nested feature here, and I'm back to the new version, the nested payload versions mapping. Customer only need to map one single basic class of the computer, the top level computer class, and associate all nested class with this single computer. As you can see here, we have those disk software, we don't have all those extra computer class. Everything is associated to the single computer. Another UI change is that when customer create a conditional class, previously we only show the field name in the condition builder, which is here. But now with nested payload, customer needs to know which level a field belongs to. Thus, we prefix the level name before the field name. As you can see here, we prefix the object, which is first level of computer, to the before the field name. These prefix will show up in the encoded query in conditional class as well, which is inside here. Other class mapping flow is exactly the same as before. Next will be the attribute mapping. Same as class mapping, I have already created the exact same required IRE attribute mapping as flat JMF mappings. But for demo purpose, I did not add those non-required attributes. First, we introduce a new field tree at the right side to better represent all fields and their corresponding levels. We also give each field a sample value to give customer a better understanding of what this field means. At this right side, as you can see here, this computer IP address, which has this, and this is a typical MAC address. Customer can still drag these fields to the SIMDB fields they want to map. In nested payload feature, we will highlight all the SIMDB fields that can be mapped to when dragging fields. So let me drag this one. So you can see here the column here of the source recency timestamp is surrounded with a green color. And once customer maps their first attribute, which is computer's first level fields here inside this section, they can only choose attributes from the level that the first map attribute belongs to. If customer tries to drag a field from other levels, then we will highlight the SIMDB field as error and show error notification. So here we already map all those fields to the first level computer's fields. So if I choose from different level, for example, software, and if I try to map here, you can see that it gives surrounded by red color, and we give the error information say that this data is not allowed. If customer wants to switch to use attributes from different level, they have to delete all currently mapped fields and downstream reference, and then we will allow them to choose any attribute from any level again. Additionally, we provide customer an alternative way to select fields. Instead of dragging pairs, they can also open the new .work picker to pick the fields from any level, which is here, this button. But same rules apply to the .work picker as well. If customer already mapped to an attribute from a level, which in this case we already mapped to the computer level, then the attribute from other levels will be disabled. So we see that those computer fields are enabled, but other levels such as software, printers are all disabled, and you cannot select them. The final mapping step is the relationship mapping. Same as class mapping, I have created the exact same relationship mapping as flat JMF, but with nested payload feature. Because we no longer need the separate computer classes, we mentioned that in the class mapping step for each of those nested class. We can just simply create a relationship between the single computer class with all nested class. Let me compare this with the original JMF computer. So right now I'm on the old flat JMF computers mapping, and let's go to the relationship page. So you can see here, because they have this extra U_type field, so they have to make it a conditional relationship. And you can see they map all those duplicate relationship of those disk computer, network adapter computer, IP address computer, just so that the relationship could be associated together. But here, we only need to create 3 simple basic relationship with a single computer class and all those nested classes, simple and clear. Another new UI change is that we prefix the level name before the field name in the conditional builder for conditional relationship mapping as well. This prefix will show up in the encoded query in conditional class cards as well. So same as class mapping, we map the level name before the field names, and they will be show up in the conditional mapping class cards. Also, because the data is nested now, it's natural that we cannot create a relationship between 2 sibling levels. For example, here you can see the software and the storage disk are siblings. So if the storage disk are siblings in this nested data tree, so we cannot create a relationship between them. If I go to the relationship page and try to create a new relationship, if I select the disk, which is storage disk as parent, the software will not show up in the child. And vice versa, if I select software, then the disk should not show up in the child option. After the customer finish all the above mapping flow, they can proceed to the preview and the rollback data page to check inserted nested data as before. For demoing purpose, I extracted 3 JMF nested computer so we can clearly see all the records are injected and associated correctly. Let's go back to the JSON data. We have 3 computers, 2 printers, 3 software. Each computer has 1 network adapter, 1 serial number, 1 IP address, and 1 disk. So in total, we have 20 records and 9 relationship, which is here. You can see the number is correct. And inside each class tab here, we can see the reference fields are all correctly associated. So here is the 3 computers we have. Inside disk, we can see that the disk is associated to those 3 computers. And for IP address, it's associated to the NIC, which is network adapter here. And for network adapter, inside the configuration item, it's associated to 3 computers. And we have those 2 printers here. Same serial number is associated to the computers. The software is correctly injected into the SAM software installation class, and it's installed on those 3 computers. And we have the NIC relationship created between the network adapter, IP address, and computer. That's an end-to-end flow for a nested payload feature.